review this later. If anyone wants to review this later, then you can go ahead and review this on YouTube. This is going to be our experiment number 2, reduction of 9-fluorenone. And today we went ahead and reviewed the lab manual prior to set up your pre-lab. Secondly, if you have not watched the video, I recommend to go ahead and watch the video of the setup of this reaction in order for you to better understand this in person, which can be found at the link here. Again, if you don't know how to access this, please go to Home. And then once you're here, you go to where we are, day 3, week 2, reduction of 9-fluorenone. Then go ahead and we reviewed the pre-lab quiz. If you hadn't completed it, please go forward to do it. But remember, this is supposed to be completed prior. And then these are going to be the glassware pieces that you're going to need for the experiment itself, which we will cover in the lab manual. So let me switch over here to our lab manual. And today's class will be pretty quick because I noticed it is such a short experiment. So I'm going to try and take it slow because it's such a short lab manual. And I greatly recommend to go ahead and watch the video as well, so that way that you can better understand. But let's take this very slowly. So we have a lot of keywords here that we're going to be talking about today. We're going to be talking about reduction. We're going to talk about ketones. Additionally, another method can be utilized in the same fashion for aldehydes and corresponding alcohol, and then the reagents such as sodium borohydride, as well as various other reducing agents are very commonly used. I'd say the 4 hydrides that are available for reduction. And then additionally, they say with regards to ketones or aldehydes, they're selectively reduced. So when they say that, they are also referencing to less reactive carbonyl groups. So let's say on one end of the chain, you have a large compound. On one end of the chain, you have an ester or an amide. And then on the other side of the chain, you have a ketone or an aldehyde. Now remember, ketones like this, 9-fluorenone, are a carbon group double bonded to an oxygen group. That clarifies it is a ketone. An aldehyde, I'll go ahead and pull up after we are done with this lab manual so that you can see. But additionally, an aldehyde would be a carbonyl attached to a hydrogen instead of an adjacent carbon. Then what happens is that sodium borohydride in ethanol can go forward in order to reduce the ketone down to a hydroxyl group. And I can show you the mechanism after as well, since this is such a short descriptor. But the take-home message today that we need to remember is that we will be utilizing sodium borohydride in ethanol in order to reduce a ketone or aldehyde to a primary alcohol, or in this case, it'd be a secondary alcohol. So make sure to remember that ketones or aldehydes can be reduced by sodium borohydride in order to create alcohols. Then the pre-lab exercise was already completed, and I'm going to go through and list out each individual thing so that way that you know what is organic or aqueous. So take notes on this part if you have not completed the waste section. So 9-fluorenone, this is organic waste. 9-hydroxyfluorine is going to be organic waste. Ethanol, this can be either organic or aqueous. I'm not going to be picky. Additionally, sodium borohydride, that we would consider this as aqueous because it is more polar and more soluble in aqueous conditions. And additionally, going forward, we would be talking here, so you dissolve the 9-fluorenone in your ethanol, then you start stirring it, slightly warm it, and additionally, we would want to have more of a dried ethanol situation, so that way that if you have water in the presence of sodium borohydride, it can actually, they call it wetting, or it saturates the sodium borohydride, leaving it inactive. And then that way you would not have any reaction going on. So you would want absolute ethanol, is what they call near 100%, probably 95%. It reduces the chance of your sodium borohydride to become inactivated by additional aqueous conditions. So commonly in organic chemistry, we want to reduce the quantity of water in organic reactions because water can be detrimental in terms of certain utilizations of sodium borohydride, lithium aluminum hydride, any sort of hydrides. They are so reactive, they are willing to go forward and pull the hydroxy group from a water and then neutralize your reagent. So then you would have a low low yield. And you don't want low yield. You want to make sure that most of your starting material goes forward and reacts appropriately. So after this has stirred and been heated for a little bit, then you would continue to go forward, and afterwards you would add 2 milliliters of water. So water we know is aqueous as well. And then don't worry about adding water into the hazard section, but I would recommend adding the 3 milliliters of HCl here. And this hydrochloric acid would be considered aqueous because it dissolves into water. Then the evolution of hydrogen, known as bubbling, would be shown by the excess borohydride reacting with your hydrochloric acid and water. Then what happens is you isolate your products by vacuum filtration on a Hirsch funnel. So make sure to describe out your Hirsch funnel apparatus, all of the glassware there. And I'm actually trying to see the instruments in this section. The only instruments I would recommend people to put there would be oven. When they say take a melting point, put melting point machine. So oven, melting point machine. And then thirdly, when they say IR analysis, you can say IR machine. So the only 3 machines that I want to see from people will be oven, melting point machine, and IR machine. All of your glassware, place it into the apparatus section. This is a very simple lab in terms of explaining forward the concepts. It really is more mechanistic. And here is the post-lab questions that you will complete in your notebook after you have gone forward with the data. So let me go forward to, let me save this one for one moment, and then I'll pull up the data and then we can take a look at that. So pulling over here into our module once more. Click here for data at the end. So firstly, let's review the starting material and products spectra. Okay, so assign the characteristic functional groups with their IR peaks. So please review back to the IR spectra, the local functional groups for specific areas. And I'm not going to give this out here because I want to make sure that you go forward in order to, learn, utilize your knowledge in IR and find out all of the functional groups here. And I have a few that I can note off just off the top of my head that I can see there. Additionally, scroll down, don't forget this. This is going to be your product. So the major thing I'm seeing here is this big shift right here. What's this big shift? That's what you need to answer within your post-lab notebook. So as you can see, since we are not performing the experiment, it is a very straightforward and simple experiment since we are only reviewing data. So please be thorough with this. And going forward into our data taken from here, make sure to review this. And since we have so many students here, in case that you are not on this list, please let me know and I will modify it to give you your own separate little data section here. And then it's very simple, your theoretical yield, your percent yield. If you need to review that, please utilize the original module. I'm pretty sure here in the safety section, if I'm not mistaken, in math, there is, yes, percent yield, actual theoretical yield, limiting reagent, and stoichiometry. If you need to review that, go here into module Safe Lab Safety Labware Math Online, and it is under number 2, section 7. Very simple concepts. However, since they are so simple, people commonly forget how to calculate actual theoretical yield and percent yield as well. So finally, I want to show you the mechanism of reduction by sodium borohydride. This is a very clean and nice reaction within chemistry labs because what happens is that we can utilize this in order to reduce very weak bonds that are not as strong or complex as carboxylic acids, esters, amides. Those are more strong and have more resonating effects, such as the hydroxyl group performing a ketoenol transformation that you may know of from organic as well. So that tautomerization will actually cause it to be enabled to be reduced by sodium borohydride. So a lot of these things in organic too will be more in-depth understandings and mechanisms that you may be learning in class additionally. So on Google here, you can see the reduction by sodium borohydride. What happens is the boron actually comes in and lets one of the hydride groups, so remember hydride, this may be a newer concept to you, but hydrides are actually a negative proton. And in this case, this is actually acting as the nucleophile. So remember these keywords, nucleophile, electrophile. The aldehyde here is our electrophile. It is being backside attacked by the hydride here. And then this resonating effect goes actually up from our double bonded carbonyl up into the oxygen, allowing the electrons to go up. Then, now that we have our two hydrogens bound here to our carbon after the addition, then we have our sodium alkoxide in a way, or in any way that we have an oxygen here with a negative charge, it actually can go ahead and bind to a local hydrogen on a water group within our system. So what happens is we let our borohydride come in, and then once we've reduced down our aldehyde or ketone, then we want to go in and add the water into our reaction vessel, so that way that our hydroxyl group can go forward in order to be, or our hydroxide group to become a hydroxyl group. So then it finally takes our hydrogen, and we are left with, in this case, from an aldehyde, a primary alcohol. In a ketone, you'd be left with a secondary or tertiary alcohol, depending. Additionally, here is the example of the sodium borohydride reducing down a ketone. So what would happen is the hydride would bind in here, then your resonating effect would come up from your ketone group. From the double bond would resonate up, the negative charge would go up into your oxygen, the electrons go up into the oxygen. Then your oxygen will go forward and attack a neighboring water group, removing the hydrogen from the water, finally being quenched in order to create our secondary alcohol. And then once again here is our aldehyde going forward to create our primary alcohol, with a side of borohydride here and a sodium salt, depending on what the additional halide is that's in the mixture. So in this case here as well, you would have a sodium halogen salt, and then as well the borohydride. Another example, let me see if I can find an actual drawing of the ketone really quick. So yeah, this is a quick example of a metal hydride. So additionally, lithium aluminum hydride follows the same pathway, where the hydride, see the negative, it comes in and acts as a nucleophile, attacking the ketone. And then this is showing a one-step fashion. So do remember that the electrons from the double bond resonate up into the oxygen before the quenching of water or acid, because we don't want to quench the hydride, okay? If you have water or acid in your mixture and it quenches your hydride first, then little to no reaction will occur. So remember, the hydride attacks, resonating goes up from the double bond into the oxygen, moving the electrons. Then your oxygen is the new nucleophile. Your oxygen has so much electrons, it wants to be quenched by a hydrogen, so it attacks the hydrogen attached to a water group in order to create the final hydroxyl group, and in this case, a secondary alcohol. So those are the primary things that I wanted to discuss today with regards to the experiment. And let me look back one more time so that way I make sure that we don't miss anything. The last portion that I would like to make sure that everyone does remember is that the HOLA discussion, it is up, and let me show the screen really quick. So it looks like we don't have any current discussions posted here, so please go forward to complete this sooner than later. Once again, the poster will be due the day after our exam, so what we need to do is go ahead and complete these here, click reply down here, and then you can go ahead and answer these questions for your 5 points for participation on that. Secondly, I want everyone to start thinking this week, what experiment are you interested in performing, right? Because you need to be starting to think about this. It's going to come sooner than later, and we only have a month in the class, so make sure to start thinking about what experiment you're going to do. Probably have that in stone by next week or the following week by latest. Please don't procrastinate on this idea. And if you need to do your poster last minute, I understand. That's totally understandable, because it is a fast-paced course and you want to get those notebooks as good as possible, right? Do really great on your quizzes, and then just make sure that the poster is due the day after our final. So please don't forget that. And then otherwise, I'm going to just come back to our reduction and make sure that I didn't miss anything. Make sure to list out all the glassware that is provided within your lab manual. All the glassware will be in your apparatus. Only the oven, the IR machine, and the, what was the last one? The melting point machine will be the 3 machines that you need in the section today. And then finally, the only thing I'm going to touch on is that next class we will have the oxidation of isoboronol. So please prepare for this. Make sure all of your glassware is placed into the glassware section. Any sort of machines you'll put into the machine section, and have your procedure ready. So that way, if I call on you for next class period, that way you are prepared, and in a sense, you will be ready to walk in and perform the experiment in case that we were actually performing these experiments in person. So please make sure that everyone has your pre-lab completed here today, or for our next lab period on Thursday. So that way, in case I call on you, you get full participation. And I will be more critical next time, since now that everyone has your fair warning. If you are missing certain things, like here or there, I may not count points off. But if a section is missing, you will receive points off for attendance. So please note that that will be the sort of standard going forward. And other than that, I'm going to go ahead and end the recording, because that is all that we have to discuss today.